Hello, welcome back to our channel. Today we are going to discuss about ray optics crash course. Already I have given 6 days program, motion in a straight line chapter, units and measurements chapter, and one more is motion in a straight line. Also I have given second year, I have given the waves. And today we are going to discuss about our day 7 plan is ray optics part 1. See, ray optics are also very important. Just I am giving the revision for like Eamcet and NEET, and this is the mains. Just like revision, we have to revise all formulas once. First of all, ray optics. What is the light? Light is a form of energy. Like sound, no, light is also form of a energy. Because of the sensation of the vision, we can able to see the objects. You are there, I am here, and everything we can able to see. But whenever we are looking directly, we can't able to see. When light falls on the object, then light rays are scattered and they are reached to the our retina. Then we can able to say that object, and we can able to see also. So because of that reason, that too, this is belongs to because of the one optic nerve, we can able to see the objects. That's why this is called the optics. In that optics, first part is ray optics, then our next part is the wave optics. Ray optics means in this chapter we are going to discuss about ray nature of the light. So light is having the straight line path. With the help of this concept, successfully they explained what is reflection, what is refraction, what is total internal reflection. Then they explained some optical instruments. Now we can able to see the micro organs also. So whenever they have been, base is coming from this only. If there is no ray optics, there is no microscope, and we don't know and we can't able to see. And now Omicron is there. We can able to give that, yes, this is the shape, and but we can't see directly. With the help of the microscope only we can able to see. But all these were developed based on this ray optics only. So anyway, in this chapter, first thing is we have to discuss about what is the light. Light is a form of energy. This light is having the straight line path. This is called the ray, and bunch of rays are called the beam is there. So in this, our first property of light is the reflection. What is the reflection? When light falls on the surface of two medias, any medium, like we are taking, this is the glass and this is the air we are taking. Air is the somewhat density is less, rarer medium, and this is the denser medium. So this is the surface, it is separating two medias. You can say that it is medium 1 and medium 2. Water and glass you can take it. Then air and water you can take it. Any two mediums, it is separated by one surface. This is partition of these two mediums. This is the medium 1 and medium 2 also you can take it. This is the normal to the surface. When light falls on the surface, no, a part of the light comes back into the same medium. This is the incident ray and this is the reflected ray. And the angle between incident ray and normal ray is called the angle of incidence I. And this is called the angle of reflection R. So what is the reflection? When light falls on the surface of two mediums, a part of the light comes back into the same medium, that is called the reflection. In our daily life also, because of the reflection only we can able to see our image. Even diamond also, there are many properties. Total internal reflection is one of the reason. So reflection is playing an important role to see the objects here. So this is the reflection, and here I is the angle of incidence. Angle of incidence. Then R is the angle of reflection. Reflection. And one more we should discuss here, angle of deviation. Look here. If there is no surface, light is having the straight line path. Okay. So the angle between reflected ray and incident ray is called the angle of deviation. Here delta is called the angle of deviation. But what is the formula of this one? Before discussing angle of deviation, we have to focus on the laws of reflection. Very important concept. Laws of reflection. Nothing is there in this first. Angle of incidence is equals to angle of reflection. This is one of the law of reflection. Suppose the question is, it follows the laws of reflection. If angle of incidence is 30 degrees, what about the angle of reflection? That is also 30. If it is 60 degrees, angle of reflection is also 60 degrees. Then Here incident ray, normal and reflected ray. All are in same plane. All are in same plane. These are the laws of the reflection. See, from this how to calculate the angle of deviation? Angle of deviation delta equals to, I am writing from here to here, total angle is how much? 180 degrees. 180 degrees minus, this is total is how much? I plus R. Just now we know that angle of incidence equals to angle of reflection. So delta, instead of 180 we can write it pi minus 2I also, since I equals to R. That's why we are taking. Few problems we are discussing based on this. Look here. See, here I am writing. Find angle of deviation. Find angle of deviation if I equals to 30 degrees. See, they didn't given anything about the reflection. We know that the hint is angle of incidence is 30 degrees. How to find out the angle of deviation in the case of reflection? When we can go through the refraction, it is other part. So reflection formula is 180 minus 2I. 2 into 30 degrees. So 120 degrees. 180 minus 60 is the 120 degrees. So this is a simple formula to remember that, but it's difficult somewhat remember. But you remember the definition. The angle between incident ray and reflected ray is called what? Angle of deviation delta. This is about the reflection. But there are two types of reflections are there. One is the diffusion reflection, another one is the non-diffusion reflection. So in this case, in first case, what happens here? Before, when the light falls on the polished surface, when the light falls on the polished surface, before the reflection and after the reflection, the rays are, before the reflection, all incident rays are parallel to each other. And after reflection, what happens? Look here, first one is this is called regular reflection. There are two types of reflections. This is the regular reflection. In regular reflection, look here, polished surface. These are the incident rays. Like this. All these are parallel to each other. After reflection also, reflected rays also parallel to each other. This is called the regular reflection. We can observe in the case of polished surfaces. The next thing is the diffusion reflections. Diffusion reflections. See, uneven we are taking. So here, like this, these are falling and there is no particular direction, nothing. All these are incident rays. After reflection also, like that, these are reflected. See, this is the diffusion and that is the regular reflection. There are two types of the reflections we can observe. Then our next thing is the reflection by plane surface. Nothing but our mirror only we can take it. So whenever we are standing in front of the mirror, plane surface, you can take it. This is the mirror. See, this, you are standing here. You are standing here. This is the object distance. But what you feel, you are behind of that mirror, like that you feel, that is called the image distance. Same person we can observe here. And this distance is the image distance. But always you remember that here u equals to v. How much distance you are maintaining, same distance, image distance from the mirror, you can observe that this is forming the virtual image. The image is not forming at the same side. So other side we can observe that image. That's why this is called the virtual image. But here there are different cases. Look, for the wall, this is the mirror. We want to see our full image, any object image also full we want to see that. But how to get the size of dimension of that mirror? It must be h by 2. Suppose your height is like 5 feet. You want to see your full image. You must take half of your dimension of that mirror. So h by 2 we are taking. This is the h by 2. This person height is how much? H, and you must take it. This is the height. The question they will ask, if h equals to 40 meters. You want to see this full dimension, full length means the dimension of mirror is how much? It must be 20 meters. Suppose 5 feet person is there. We want to see full image. How much we are taking? The mirror size is wall we are fixing, no? So that must be how much? 2.5 feet. So average human being height is, we know that based on that, while constructing the and while doing the interior, they are making the mirrors and they are adjusting like that. So this is the size of the mirror to see the clear image. And one more question is there. See, we are taking one room and you are standing here. Here one mirror is there. Now we want to see clear image of this person. In this case, the height of the mirror is the h/3. Don't confuse. This is side of the wall. It is fixing h/2. And this one, we are taking one room and top of that one we are adjusting, and we have to see the full image. Means that dimension, that length or height of the mirror is must be how much? h/3. So till now we discussed about reflection by the mirror and different cases. Even just now I said u is the object distance. This is the object distance. And v is the image distance. Image distance. Suppose object is moving away from the mirror with how much velocity? Like 4 meters per second. At the same time, this image also we should observe, it is, we are moving away like this, image is also moving away like this. Both are having the opposite direction. So suppose here this is 4 meters per second object distance, and this v is the 3 meters per second. Whenever it is moving towards this, and this is also, image is also coming towards the mirror like this. Relative velocity is how much? 4 plus 3, 7 meters per second. In the second case, if it is moving 5 meters per second away from the mirror, same thing you should observe this. This is like moving 4 meters per second. Here also both are moving opposite to each other. 5 plus 4, relative velocity is how much? 9 meters per second, but we can show with negative sign. Like that, in the case of movement, in the case of moving bodies also, we can find out the object velocity and image velocity. Because relative velocity we know we can find it, and individual velocities also. The question they will ask like this: you are moving towards the mirror 5 meters per second. What is the image velocity? You can say same like this, 5 meters per second, but it is moving towards us. So always you remember that these are maintaining the opposite direction. That's why you can take it relative velocity is u plus v. So this is about the movement of that person or velocity of that object in front of the mirror. Then our next concept is, till now we discussed about single mirror. Single mirror, these are the different cases. Suppose we know that these days we are using the special effects. One person is there and we can see like that person is looking like 10 images, 10 persons are like that. So how it is possible? We are using the two mirrors, and based on that angle also we can observe number of images. Look here, the basic formula for this. If we are taking the mirrors and we can incline an angle of theta. At that time, how many images we should observe here? That is completely based on the angle between the two mirrors. Angle between the two mirrors, that is also possible because of the reflection. Look here, we are taking, this is the mirror M1 and this is the mirror M2, like that. How much angle is here? Theta. Here M equals to 360 by theta. 360 by theta. See, number of images equals to M minus 1. When even M is odd and M is even, we should observe that number of images is M minus 1. Look here, if theta equals to 30 degrees, M value how much? 360 by 30. So M value 12. But don't give the answer of 12. Number of images, how many are there? We can say that number of images equals to 12 minus 1, 11. So like that, it depends on the angle. That too, after that we have to subtract that one. Suppose we got the fraction. Look here, if M equals to 11 point, otherwise 12.23. In this case, number of images n equals to, we can take it only 12. Don't take the fraction of that one. This is the number of images. This is about the reflection by the plane surface or polished surface or mirror also, you can take the example. Then our next concept is reflection by the spherical mirror. Reflection by the spherical mirror. Look. But curved surface also we can say that. Reflection by the curved surfaces. But there are curved mirror also, you can say that. There are two types of curved mirrors. One is the concave, another one is the convex. See, we are taking like this and we can cut like this one, then we can get two types of curved mirrors. One is the concave mirror. One is the concave mirror. If the reflection takes place inside, inner side of this curved surface, you can say this is called the concave mirror, and this is called the pole. This curve type is there, no? That is called the center of curvature. This is represented by C. And from here to here, this is called the R. R is the radius of curvature. R is the radius of the curvature. R is the radius of curvature. And here O is the optic center. O is the optic center. O is the optic center. Like that, one more is the convex mirror. Convex mirror. If the reflection takes place outer surface like this. Like this. This is the convex. As usual, this is the center of the curvature, the distance is R, and this is the optic center, O, like that we are taking. And here also we can observe that reflection based on the position of the object. We can go through the one chart, then easily we can understand this topic you are having in 10th class also. While discussing the spherical mirrors, is it convex or concave, that sign convention is must. Based on the sign convention only, we can find out the magnifying power, focal length, image distance and object distance. And basics also we have to know that. Look here, already you know that the line which is passing through the center of this one is called the optic center. It is represented by O. Is it convex or concave? Look here, even we are taking the convex also. Convex also, here it is partially coated, and this is the optic center. This is the optic center. If we are placing one object is here, that is the distance is the object distance. Mostly we are taking the U. And image we can observe this wherever, even this side, that side, that is called the, suppose image is here. And this is the image distance like this. See, when after reflection, where the all rays are focused, that point is called the focal point. And the length from the optic center to here F is there, no? So this is called the focal length. So object distance from the optic center is called the object distance. Mostly we are representing with U. And image distance is from the optic center. Here why I am stressing from the optic center only. You can measure the object distance, you can measure the image distance, and you can measure the focal length also. So but sign convention, how can you take it? If the rays are along the incident rays, you can take positive, and opposite to the incident rays we can take the negative. What is the meaning for that? Nothing is there. Suppose, look here, first case, this is the optic center, this is the focal length, and this is the center of curvature. In this case, we are placing the object is at infinity. Object is at infinity. See, infinity to the rays are passing through the, whenever the rays are passed through the focal point, after reflection, these are parallel to the principal axis. See, this middle is called the principal axis. This is the convex and concave, whatever it is. This axis is called the principal axis. If light falls on the focus after reflection, what happens? These are passing parallel to this one. These are called the paraxial rays also, we can say that. See, in this case, if the object distance, here incident rays are coming like this. Object distance we are measuring from optic center to that infinity, minus we are taking. Opposite to that rays we are taking the minus. Even image also, this is formed the real image. Here object and image both are at same side, both are measuring opposite to the incident rays. In this case, image distance and object distance both are negative. Generally mirror equation is what? 1 by f equals to 1 by u plus 1 by v. Here u is the object distance, u is the object distance, v is the image distance, and f is the focal length. Don't confuse. You know the basics also from the 10th class. See, if we are measuring object distance and image distance opposite to the incident rays, you can say those are negative. When these two are negative, automatically our focal length is also, we are measuring from the optic center, that is also negative. So in first case, you look here, object is at infinity, but you are measuring from optic center to opposite to that incident rays. So in first case, image distance is negative, v is negative, f is negative, and u is also negative. In this case, when the object is at infinity, we can observe that real image is at same side, object is at same side, and image is also at same side. That's why this is the real, and object is the inverted, reverse we can observe that. When the object is at infinity, image is the reverse of that one, and that too very small image, that too where we should observe at focal length. These are the rules here. See, whenever the object is at infinity, we can observe the real, inverted, and very small image, that too which point at focal length. Here we should observe the image like this. Second case, if object is beyond, see, this is beyond the center of the curvature. This is the object. From here to here, you know that this is the object distance u, and here we can observe this image. So I is in between focal length and center of curvature. You are standing here, your friend is standing here beyond the center of curvature, but that friend image we should observe in between the focal length and center of the curvature. Then our next diagram is, see, here where is the object? Object exactly we are placing at center of curvature, not before that and not beyond that, exactly at center of curvature, but inverted, same position we can observe. Like we are standing that lake, no, and we are looking exactly our image we can observe, no. So it is inverted. Here image and object both are at same position. Then in this case, where is the object? Object is placed in between the center of curvature and focal length. Here we can observe that image is after the center of curvature, that to large image. Till here we can observe that small images. After that we can observe the large images. Don't underestimate this. Based on this only we are using the lenses also. Lenses other topic, don't confuse. Any problem, any no, these days we are using the lens, mirrors for each and everything, special effects, and for any problem in our eyes, short distance and long distance, that also we are overcoming with the help of the mirrors and with the help of the lenses. And these already you got in 10th class. The basic of this one is the mirror equation, 1 by f equals to 1 by u plus 1 by v, and you should study and you should remember that if object is at infinity, immediately you can say that image is formed at focal length like this. If the object is beyond the center of curvature, then image is in between focal point and the center of curvature. If the object is placed at the center of curvature, image is also at center of curvature, but it is real and inverted here. Real means same side, virtual is the other side we are getting. The next thing, we are placing the object in between the center of curvature and focal length. We can observe the image after the center of curvature but large. If the object is at infinity is over, now we are placing object is at focal point. We can observe that image is at infinity distance. So these are the different positions of that one. On this concept we do one problem here. The question is, if your face or any object is in front of the mirror, but he observed that his image is 2 times of that one. So you should remember that there are different types of magnifications, lateral magnification, aerial magnification, and in terms of height also we can observe. Always you remember that common formula is image height by object height. It is in terms of height. Image distance by object distance in terms of that distance, object and image distance. Image area by object area, aerial magnification. So like that clearly we should observe that image is 2 times of that original. That too we can take here u in front of the mirror means u is the negative. We are measuring opposite to this one. So u equals to minus 20 centimeters, and magnification clearly 2 times of that one means we can take it minus 2 equals to b by minus 20. B is how much? 40 centimeters. Then here 2 more questions. We should find out the focal length. We can find out the radius of curvature. So how to find out the focal length? From the mirror equation, 1 by v plus 1 by u. So 1 by f equals to 1 by 40 minus 1 by 20. After taking the LCM and all these simplifications, here we are getting 1 minus 2. Finally f equals to how much? We are getting f equals to minus 40 centimeters. Sign convention. Then radius of curvature, it is positive. We are taking r equals to, you remember that f equals to r by 2. Then r equals to 2 times of that focal length. So 2 into 40, how much? 80 centimeters. See, in single problem, based on this magnification and object distance, we can able to find out the focal length, radius of curvature, image distance and all this. So like this they are asking the problems.